Hey, what's up everybody? Welcome back to another Prepworks Tutoring video. Today we're going to be talking about translations. So, what are translations? Well, translations are basically movement of figures, objects, things like that. So let's just write this equal to movement. Now, it's not a word-for-word translation to movement, but in geometry, it's a translation basically refers to when you move a point or a shape a certain distance. So, let's just draw a little example here with a point. So let's say, let me change colors real quick. So let's say we had this point right here. We could call this point A, and then if we want to translate it, basically moving the point, so we can move it, up and down, right and left. Let's just move it to the right, and we can call this new point A prime. So this is going to be called the pre-image because it's the pre-image, and the image is basically the image or the figure that we have after we perform the translation. So a couple things here to note for this one little example here. We're going to go over the properties or the basic properties of translations because it's super important to know the properties of translation. So basically here you can see how basically when you perform a translation, it's only gonna move in one direction. Now it's a different story if you perform multiple translations. So I could, move it to the right and then move it X amount of units up and down, and that's just a completely different story. And I forgot to mention that you could actually perform translations on the grid, off the grid, and it's very similar for other transformations. So let's just write down the property here. So there's only going to be one direction. So that's the first thing that we want to note, and let's move on. So in the last example, we looked at something that was sort of, more basic. It was one single point. So what if we looked at something more complicated? Let's say we had a little square here. Not the best looking square, but it is what it is. And we're going to label the vertices A, B, C, D. It's going to be translated to the right as well because we love translations to the right. And we're going to label this A prime, B prime, C prime, and D prime. All right, so let's see what's happening here. Well, there's a couple things that we can actually represent. So if I take a different color, and the first thing I want you to notice is that the distance between the points are going to be the same. And so a good way to represent this is by connecting the corresponding vertices. So A to A prime, B to B prime, etc. So let's just, oh my god. All right, let's do that right now. So A to A prime, B to B prime, D to D prime. Oop, that didn't quite connect. And C to C prime. So you can see how it's going to all connect. My corresponding lines are kind of off-centered, but it is what it is. It's okay, and we will move on. So what we can actually draw here is a vector. Now, a vector is just a line segment in geometry, or when you're talking about geometry, it's basically a line segment that can measure the distance and the direction. So let's say I were to draw it for D to D prime. So it's going to be something like this. We could call it, I don't know, I guess X and Y. And so X and Y here, this is going to be the vector for D to D prime. And you can see how these two lines, so D to D prime, that line is going to be parallel to X to the vectors of X, Y. So let's write this down, the line corresponding, nope, not the line corresponding, the line connecting. You have to fit this here. Corresponding points is always parallel to the vector. And that is our second important point. Now, the next important point I want to look at, it's much more simple than having to explain a whole vector thing. But basically, when you translate something, it's going to be the same distance. And I think that I've already mentioned this, but A to A prime, B to B prime, that distance is going to be the same. So let me just write this out, and so it's easier to visualize. So we have A to A prime. So that's going to equal a distance. So let's just say that's distance x. Now that might be a little confusing with my vector here, but it's going to make sense in a second. B to B prime equals distance y. And x equals y. So the distances are the same, and so the units that are being moved are going to be the same as well. Alrighty, so the final little thing here for translations is going to be orientation. Now, what exactly is orientation? Well, you're about to find out. So let's say we take a trusty triangle. So we have a nice looking triangle right there, A, B, C. And I'm going to show an example of something that does not preserve orientation. So I'm going to draw another triangle. And then let's call this A, C, B. So what is the problem here? Why does this not preserve orientation? Well, orientation is basically when you have something in order and you're looking at it from clockwise or counterclockwise, it should match up in terms of order. So what I mean by this is, let's say I start at the top. So I'm going to start at this top point here. Let me use a different color. And let's say we go clockwise. So A is going to go to B, B is going to go to C, and C is going to go to A. However, if we look at this on this side, we have C. So C is going to B, B is going to A, and A is going to C. So you can see how that's not in the same order as we had before. Because, we just take the first example. We have C going to A in the first example, yet we have C going to B over here. And so this does not preserve orientation. So this does not preserve orientation. Now that's not the case with translations, because translations, as we know, do in fact preserve orientation. So example of that would just be, let's say we have, let's just return to our squares. So we have a square here, A, B, C, D, A, B, C, D. And I'll keep in mind that in the future I'll use other shapes. So let's see, we translate this, and this does preserve orientation. Now highlight that. All right, so why does it preserve orientation? Well, you can see, let's say we have A going to B, going to C, going to D, and going back to A. So that is in clockwise. And then for the same figure here, it's the same thing. So that just about does it for this video. And you can see how all the little properties of translations are quite cool to see in action when you really break it down with some diagrams. And yeah, I hope you guys learned something. If you have a question, just drop it down below in the comments. And yeah, thank you for watching.